welcome everyone, and thank you for taking the time to join me today on the topic of compliance to culture. You may have heard earlier in the sessions today, but also, just from your experience itself, the scale and nature of the engineering environments that we operate in has always fascinated me. I started off my engineering career contributing to the design and commissioning of extra high voltage substations. So it was here that my first sort of interaction with cyber risk and safety came into play. And in 2017, I registered as a professional engineer using cybersecurity program outcomes. And I was able to then meet all of the engineering outcomes required by the Council of South Africa, and was able to then take a lot of the learnings that I have and adapt it to other clients and landscapes. So I'm very excited to be here today with you to share some of the experience that I've had in the space. So fast forward to today, a lot has changed. I mean, from 2017 to 2025. For example, robotic manufacturing is here, and it's here to stay, and it's really helping us fast track and drive down costs in a lot of our manufacturing environments. It's given us a huge competitive advantage. Sustainable cyber risk management, therefore, cannot be solved with one-time investments or siloed technology approaches. Your competitive advantage lies in embedding cyber risk management at a process level, backed by leadership and aligned to business risk, owned across all levels, and especially on the plant floor. Because what I found in my experience, treating it like it's a task, one activity at a time, does not last. Most importantly, and I mean, if you've practiced in the space, you would have realized treating and kind of logging the activities that relate to cyber risk in an Excel spreadsheet can easily go unmanaged. So today I hope to leave you with a few ideas from my experience that may help you to do it differently and get a larger, wider result that you can then use and showcase in your environment. So to take you through the journey, we'll go through in the next 20 minutes. In the first half, I'll do my best to walk you through a journey through the lessons and the path that the safety culture journey has gone and taken. In the second half, we will draw inspiration from the safety culture journey, and I will share an approach we could use to move cybersecurity from a compliance-based activity and start to embed it in an engineering process and practices. I'll do my best to share as much as I can in the short time, but feel free to reach out to me afterwards if you have questions, but also if you want to take the conversation further. So when I started really thinking through this philosophy and sort of looking at safety and drawing insights from it, one of the key questions that I asked is, what if we apply the safety culture architecture to cyber risk management of the plant environment? And that then led me to a lot of what I'm about to share with you today. If we had to just take a brief look into the history of the safety culture journey, safety wasn't always what it is today. Decades ago, workplace accidents were common and often accepted as the cost of doing business. It took large-scale disasters like the Flexboro chemical plant explosion and the Chernobyl nuclear incident to actually expose the failure of reactive systems. And you might also, in your experience, see that the similar is happening with us now in cyber risk, where we're taking a very reactive approach to this risk. The EU Framework Directive in 1989 was a turning point for all of us. It moved safety from a compliance task to a proactive responsibility. Companies began involving workers in risk assessments, and then came behavior-based systems, a psychological and organizational shift that treated unsafe acts as a cultural act and not just a procedural one. Over the next 2 decades, companies began integrating safety into their engineering processes and leadership KPIs. Some of the impacts of that change in approach led to the European manufacturing sector, for example, seeing a 65% drop in fatal accidents from the early 90s to 2014. And I just want to draw your attention. I mean, that's close to 3 decades of change that needed to happen. In South Africa, Polyfin Chemical went from a high injury rate to a world-class safety performance by embedding behavior-based safety. They didn't just train workers, they built safety into every engineering change. And, coming from my own background, starting off in the electricity production and transmission of power, we saw a huge shift once we started applying a zero harm context, which is a huge system, well, a comprehensive system that included technological, people, and process controls to help manage the entire ecosystem, but also to give the results that resulted in long-term behavior change. So fast forward to today, we're now experiencing something very similar with the cyber landscape. Cyber risk management is often delegated to the IT department and a compliance approach is taken. We are currently driven by compliance directives and legislation, which, by the way, is changing at such a fast pace. So the cost of actually complying is increasing as the days go on. Operational teams, engineers, control room supervisors, plant managers often don't see their role in ensuring the plant is cyber secure yet, although the impact is often felt on the plant floor should a breach occur. Take the cyber attack on Norsk Hydro, for example, that occurred in 2019. Just to refresh our memory of what happened there, one of the largest aluminium manufacturers was hit with a ransomware attack that affected their operations globally. The company's IT and OT systems were disrupted, their entire value chain interrupted, leading to a significant financial losses, but most importantly, operational setbacks. This attack highlighted to the manufacturing industry as a whole that it's not just about the financial implications, but also the potential safety hazards that come with such incidents. Closer to home here in South Africa, in July 2021, our largest port and rail company, Transnet, also experienced a ransomware attack. It severely disrupted operations, including at the critical port of Durban. The cyber attack resulted in manual cargo processing and declaration of force majeure, which significantly slowed down operations that led to widespread logistical delays, not to mention huge impact to revenue for a couple of weeks. Some of the typical risks that we face in this area, or shall I say exposures, include insecure remote access, insecure logical access, management to key systems, and unpatched HMIs, just to name a few. With manufacturing digital transformation, where remote access, machine-to-machine control is common, we can no longer say that these are just IT issues. It suddenly stems and becomes an engineering problem. We're repeating the early safety mistakes. We're relying on rules without culture and the technology with the right plant practices and behavior. So with that, may we please have the first poll. Colleagues, in your context, when your engineering or operation team makes a system change, how often is cybersecurity risk considered as part of the entire design, implementation, and change process? Okay, it's interesting to see that we have almost quite a balanced view in terms of we're sometimes doing it, always doing it, really, and never doing it. Well, it's actually good to see. And I'm happy to see that a lot of us are sometimes and always doing it compared to really and never doing it. It means that there is change that is occurring and that we are being supported in our efforts to engage and ensure good practice. Okay, So what if we take a safety culture approach to cyber on the plant floor? What could that look like? So imagine an environment where your engineering and plant maintenance team catches cyber risk before IT ever sees it, because they were trained to, and because they had the tools and the processes to support them. What would that look like? Because the cyber risk assessment and impact were now part of the engineering design and change processes. Cyber risk assessments were part of the forms that engineers and maintenance engineers and design engineers had to complete as part of the engineering change process. That's what we saw that made the impact with safety. Engineers and frontline workers took ownership of safety. Each person played a role in reaching the zero harm KPI targets. So my theory, the same can be done for cyber. When operations, engineering, and IT share the ownership, we see coordinated cyber risk control, fewer surprises, and a more resilient operation. It's about creating a new way, a way that incorporates learning from our safety journey. So here's an approach that we could take to actually embed cyber risk management proactively into the engineering change management process. If safety taught us anything, it's that risk needs to be addressed throughout the plant lifecycle, especially at the point of change. For cyber, that means during the planning, design, commissioning, and maintenance of the plant. It means during upgrades and when vendors are brought in, and vendors are part of the entire asset lifecycle. With the ease with which adversaries can launch attacks today, cyber risk can no longer be something that we think about at the end of our design of our systems. And honestly, in my experience, it's a way more costly exercise to incorporate controls at the end. And securing budget in an OPEX specifically for this can be really, really challenging. Therefore, a cybersecure culture starts by shifting it from an IT problem to an engineering problem, making cyber part of daily decisions. Here's a simple plant cyber risk management approach that you can adopt. It consists of 6 areas for opportunities to insert cybersecure practices and behaviors. For example, and I've actually put up some commissioning questions, for example. When adding a new piece of automation, a plant engineer could ask during the site commissioning any one of these questions or all of these questions. How will the system or device connect to the network? How are we managing logical access? You will notice that these questions are open-ended because then it will give rise or show us the various scenarios that a cyber threat model can be built around. So the key message here, everyone, is that we don't need massive change to actually make an impact in this space. We can leverage the existing processes that we have to make step changes that would lead to large results. We could start small, maybe by adding 5 cyber risk questions to your engineering change request form that is then a priority to be answered before moving to the next step of your workflow. Maybe it's running a 30-minute awareness session every month to your plant engineers to ensure that they're aware of the emerging threat, but most importantly, the techniques that adversaries are using to exploit these vulnerabilities in these environments. Maybe it's requiring cyber sign-off for changes to OT networks and plant commissioning. You don't need a brand new policy. And this is something that I think is really, really important and can confuse the environment. Too many policies are difficult to actually adhere to, but also from a technical control perspective, challenging to implement and sustain. So maybe it's just a matter of revising your existing ones to include cyber risk management. What safety has shown us is that it can be possible and that alignment between risk and plant routine is critical for its success. In my experience and what has worked is when we find the high leverage points. So the points in the process that require change, for example, And the everyday workflows and procedures, the standard operating procedures, are adapted to include cyber risk hygiene practices. There can be a cultural nudge that occurs that can reduce plant exposure. So to conclude, and to keep this really short and sweet today so we can have an overall discussion, one of the most powerful outcomes from the safety culture evolution was psychological change. Workers began to believe that their actions mattered. Leaders reinforced that belief by showing up and walking the plant. Started having meetings with safety moments and rewarding safe behaviors. They made safety a leadership issue, and integration made it sustainable. Safety was built into engineering change processes, procurement decisions, even contractor onboarding. You're not allowed on site without first attending a safety briefing, for example. You can't do your job without touching safety in any aspect on the plant floor. So what if we build the same cultural architecture for cyber? With leadership walking the talk, systems reinforcing the behavior, and workers understanding their role. So to help you with this journey, I have created an engineering change management template for you to get started. However, it seems by our poll results that maybe it's not something that you would need, especially if you're have already built cyber risk assessments and sort of methodologies into your engineering change processes. Thank you for being part of this conversation. If anything I shared resonated with you, please feel free to reach out. I'm extremely passionate about the subject and building systems to actually support the ongoing governance of the engineering environment when it comes to managing cyber risk. Thank you so much.
Thanks, Michelle. No, I appreciate that. Yeah, and sharing a lot of that resonated, I think, hopefully with a lot of folks. I know it did for me, being in different control system environments, of course, working for an engineering company. there's definitely a lot of crossover. I don't know if anybody has questions. If you want to chat, drop them in the chat. You don't have to worry either the QA section. I really appreciate you putting the engineering change management template together for everybody. I think that's very cool that you took the time to do that. So definitely be sure to check it out. I really liked how you had the list of questions that engineers can ask, especially like when you're talking about in commissioning, right? And looking at different assets and asking those questions as far as who is going to have access to these systems. Because a lot of times that's, a lot of those questions aren't being asked. And if they're not being asked, then those issues aren't being addressed, of course. So definitely a big issue. And one of the other things that you highlighted was talking about you getting to the point where engineers can help in the risk assessment process, right?
Yes.
Where we can get engineers to the point where they're able to do, even at maybe a high level of risk assessment, the cyber component as they're going throughout their other work. So what are some of the things that you feel that we can do to help engineers get to that point, right, where we can empower them to do the cyber risk portion?
Well, a threat model is really helpful. I think engineers are programmed and as part of the engineering design process to look at various scenarios and to evaluate the plant's resistance to those various scenarios. So I think, for example, if you have an IT team that has the cyber skills and understands the various threat landscape and threat vectors and the vulnerabilities that can be exploited, for them to create some kind of threat model to help engineers actually think through that as part of their assessment. And by doing that, make it easier for them as they build their own skills in this space, because there's a lot to manage when it comes to that environment, and just assuming that everybody can do everything is not a way that will help us kind of mature the environment at the pace that we need to mature it.
Right.
We were very lucky in my opinion, with safety, in that it took us 3 decades, and we had the space to do that. But when it comes to the cyber threat landscape, with the changes that are happening and the adversary tactics, tools, and techniques that they have, it's, we don't have time is not something that we have to our advantage in that space.
No, not at all. And Rob Lee had done the keynote at this year's B-Sides ICS conference, and a big focus for him. And this goes back to even when he was still with Mike Asante, when Mike was alive and was, Rob's mentor, but talking about, we're not prepared.
Yeah.
And so many environments are not prepared, and kind of like what you're saying, we're running out of time. We basically ran out of time, and it's just a matter of time before each environment gets hit, unfortunately, just like in the IT world, right? So it's not a
Yeah.
question of if, it's only the question of when.
When, 100%. And Mike, it's fun. If we had to look at adversaries, they're probably thinking, it's fun for them to actually figure this out. So we're dealing with highly motivated people who not necessarily want to, in all cases, um, cause harm, but would definitely want to see how far they could go. So I think with that being the context, and we just being reactive is not going to be a way that will keep our plant safe. And because safety is such a huge impact here, it's just not a matter of, oh, well, we're going to spin up our servers again and recover as quick as we do with IT systems. There's a lot more that goes into planning, bringing up a system, especially, for example, if you have a six-pack power station where there's dependencies in bringing something up. So, while, for example, technology is there to help us with the, intrusion detection and being able to detect threat, we need to consider, how do we recover? How do we bring up these multiple different systems if we don't have visibility? Because yes, we can bring it up, but can we rule out that we have an adversary that's in our network? So yeah, it's very interesting. It's a complex engineering problem that I think it's a great time to actually solve for it in a collective nature.
Yeah, and it's great. It's going back to Rob's keynote, one of the other things that he focused on, just that you had mentioned is really when you do have an incident, whether you think it's cyber or not, right? We have to be performing root cause analysis to understand, right, what happened in the environment. And maybe your SIS tripped, and it's like, okay, well, why? It's always good to understand what actually caused that issue before you just start turning the plant back on, because you don't know what type of risk that
Oh,
you're actually taking when doing that.
100%. Yes. And the impact to that in the long term, because it's easy to just go unnoticed and undetected and have a repeat incident later on because you had not taken the time to investigate if you did have an intrusion or not.
Right. And more than likely it's not an attacker, but you have some other type of issue in the environment that needs to be addressed, for sure.
100%.
And yeah, definitely. Well, thank you for coming and sharing with everybody.